A multiplexer, MUX for short, is a digital switch, which selects one out of the many input signals, and connects or forwards this selected input to a single output, so it is also called a many-to-one circuit. It can have n inputs, D0, D1, and so on till Dn-1, from which one will be selected, to be forwarded to a single output, Y, using M-select inputs, S0, S1, and so on till Sm-1, where M equal to ceiling of log n to the base 2, and the whole circuit would be enabled or disabled using an enable input, En. Such a MUX is denoted as n is to 1 MUX. Even though we say that MUX is a digital switch, it differs from a mechanical switch in one key aspect: it is unidirectional, unlike the mechanical switch, which is bidirectional, that is, information flows only from the input, on left side, to the output, on right side. The figure shows n is to 1 MUX equivalent circuit, with n data inputs, m select inputs, an enable input, and a single output. Any one of the n data inputs can be selected depending on the m select inputs, and forwarded to the output. If the circuit is enabled, information flow is unidirectional from left to right. The adjacent figure shows n is to 1 MUX block diagram. A2 is to 1 MUX selects one out of two inputs, D0 and D1, and forwards it to a single output, Y, depending on one select input, S0, since here n equal to 2, m equal to ceiling of log 2 to the base 2, equal to 1, and the logic equation is y equal to D0 and not S0, or D1 and S0. The 2 is to 1 multiplexer truth table is shown, with two inputs D1 and D0, one select input S0, and one output Y. We see that when S0 is 0, D1 is X, that is don't care, it can be either 0 or 1. The output Y follows the input D0, if D0 is 0 Y is 0, if D0 is 1 Y is 1, when S0 is 1, D0 is X, that is don't care, it can be either 0 or 1. The output Y follows the input D1, if D1 is 0 Y is 0, if D1 is 1 Y is 1. The figure shows the 2 is to 1 multiplexer symbol, with two inputs D1 and D0, one select input S0, and one output Y. 2 is to 1 multiplexer using logic gates is also shown. An inverter is used to obtain not S0, D0 and not S0 are given as inputs to an AND gate. Its output is D0 and not S0, D1 and S0 are given as inputs to another AND gate. Its output is D1 and S0. The outputs of the two AND gates are given as inputs to an OR gate, whose output Y is D0 and not S0, or D1 and S0.